Hello everyone, the power of pi, and today we're going to be looking at the 2021 AMC12A problem number 23. So it's a long problem, so I'm just going to summarize it for you. So Freda the frog is hopping around in a 3x3 grid. So she starts at the center, and in each move, she can either move up, down, left, or right. However, if she's, let's say, over here and decides to move up, she basically wraps around the grid. So she'll move from the top center square to the bottom center square as follows. And similarly, for this, it's defined in a similar manner. So we want to find the probability that she reaches a corner square for the first time in no more than 4 moves. So let's see how we would approach this. So I'll define some notation. So let's Cn equal the probability of reaching corner first time in n moves starting from center. So what's the other state that's possible? She can either be on the center or she can be on the edge. If she's on a corner, we call that done. So En would be the exact same, defined the exact similar way, but starting from edge. And now what we hope to do is relate Cn and En. So let's move on to a different slide. So Cn, what's Cn? The probability of reaching a corner in at most 4 moves. Well, from center. So from the center, she is guaranteed to move to an edge. And then the problem simply becomes, I need to reach a corner from an edge in n-1 moves. So Cn is nothing but En-1. And En would now be what? From En, we have 2 moves that'll reach us to a corner. So 1/2 chance for that. With 1/4 chance, we go back to the center, and then it becomes getting to a corner in at most n-1 moves, which is Cn-1. Or we can go to another edge. Again, we'll wrap around with 1/4 chance, and then we need to now reach a corner in n-1 move starting from an edge. So these are our 2 recurrence relations defined for n greater than or equal to 1. Or actually, better yet, let's just manually compute some of these values. So n, Cn, En. So I'll just create a table of our values. So for n equals 1, from the corner, we're guaranteed to move to an edge. We can never reach a corner, so C of 1 would be 0. From an edge, we have a 1/2 chance of moving to a corner. And then now we can just recursively use our definition. C2 would be E1, which is 1/2. And then En would be 1/2 plus 1/4 times 0 plus 1/4 times 1/2. That's 1/2 plus 1/8, which is 5/8. For 3, this becomes 5/8. And then En would be 1/2. I'll just write it here. 1/2 plus 1/4 C2. 1/4 C2 is 1/8 plus 1/4 E2, which is 5/32. So this is equal to 16 plus 4 plus 5 over 32, which is 25 over 32. So our goal is to find C3, and we see that's really just equivalent to our goal is to find C4, which is equivalent to C3. So 25 over 32 should be our answer. That's choice D, and we are done. So hope you enjoyed this nice kind of states problem. It's pretty common. Make sure to like, subscribe, and I'll see you in the next video.